Hi, y'all. Making the video that I said I would do in period 6 today. So, one thing of note, and I mentioned this to period 1, if I go down here into my additional resources, it will bring me here with all the resources. The first one is a reference sheet, and this is the page that had all of that information in there about what rotations are, what reflections, what translations are, as well as the descriptions of them, right? If we're moving this A to the left 5 units, my face, 6, excuse me, translate 6 units to the left, so it's going left, that means I would do 2 minus 6, which is where that 4 comes from, and 5 units up, that is how I do up is plus. So 1 plus 5 will get you to that 6, right? So that's how we do it. On those reflections, it is telling us how to do it, right? If we're reflecting over the x-axis, that means our y values are changing. So we would keep our x value the same. -7 stays -7, but this +6 will flip to -6. Conversely, if it flips over the y-axis, then that means your x values will change. -7 will become +7 while the 6's stay the same. If it's reflected over the line y equals x, we didn't talk a whole lot about this, but what happens is the x value becomes the y value, and the y value becomes the x value. So they flip their values, okay? Not changing any signs or anything like that. It's just the first one becomes the second one, and the second one becomes the first one. As you can see here, it goes -7, 6, and then it flips to 6, -7. All right. And then we talk about our rotations here, and there are lots of rules to remember, and these are them. This is a reference sheet, right? So use it for that. All right, I'm going to go back for just a second. And what I wanted to show you today in our weekly learning is this Quizizz practice. So I'm going to play as if I'm a student. Here we go. All right, annotation tools up. Bring that over here. All right, which rule describes the translation from the pre-image to the image? So if I select this, I can see what it does, and I'm going to draw on it. So my pre-image is this one. Remember that pre means before, and image is what it looks like. So this is what it looked like before. I can tell because A does not have a prime on it. This is that prime that shows me that I went from here to there. All right, so I want to see what I did. Which rule describes the translation? All right, so I'm thinking X goes left and right. Right, left is negative, right is positive. Y goes up or down. Up is positive, down is negative, right? Okay, so this is going left, left, 2, right? And left tells me it's negative, so it's x minus 2. And then it goes up, 1, 2, 3. Up is positive, so it'll be y plus 3. All right, so that is what my answer shall be. Will it let me do it? Yes. Okay. Sorry for some of the things here. Okay, I won't worry so much about them, but we have x minus 2, so it cannot be this one. That's x minus 2. This is x minus 2. This is not x minus 2. This is x minus 2. And then I want y plus 3, not this one. It must be that one. All right. Next one. Good job on doing those, the other ones. The following shows the construction of a line that is parallel to AB. Which of the following statements is false? So I need to look at this better. Which of the following statements is false? Well, I'm going to have to look at both. is DB, I'm going to write this up here so I know, DB, and remember that sign symbol means congruent to CB. Is AB perpendicular to BD? I'm just writing these down so I can see it when I get it up. CD is perpendicular to BD. Remember that symbol there, the upside down T, means perpendicular. All right, so now I have these to refer to. Okay, is DB congruent to CB? So DB is here, right? Is that congruent to CB, which is would be here, right? No, I think what it's trying to say, that has something to do with your perpendicular bisector, right? There's something with that, but these DB and CB aren't congruent, so that one is not true. So that one's the one that's false, but I'm going to look at these other ones and explain them. Is AB, so this is line AB, maybe I should use a line tool, that would be helpful. Is AB perpendicular to DB? Yes. If I did it on there, it would have been better. I don't think it lets me do that. I'm going to do it again. But yes, it is. These two are perpendicular. That's how they created this parallel line. They did two perpendicular lines. So we could test that out, but I know from this drawing that that's the case. And then the other one is CD perpendicular to BD. Yes. All right. This is, I'll try to color it orange. Is this perpendicular to that? Yes. The reason that we know that these two lines, that this red line here and this blue line there, this line and this line, the reason I know that they're parallel is because both of them are 90 degrees to line BD, right? And any two lines that have these interior angles, and this is a little beyond, but you'll see it in a few weeks, if these two interior angles here add up to 180, then we know that these two lines are parallel, but that's a preview. So we know the answer, which of these statements is false. It has to be this one. Hooray! Okay, next. All right. Oops, I almost accidentally did this. This transformation is an example of, all right, so it moves or it slides from here over and up. It didn't rotate. Remember that the reflection is a flip. The translation is the slide, so that's going to be my right answer. A non-rigid transformation. We haven't talked much about that. Talked about that. Don't worry about my spelling. Right? But I do remember, I will say on this one, rigid means that it stays the same shape. Stays same, oh my gosh, shape. Don't judge. So if it's non-rigid, that means it's not staying the same shape. All right, I'm going to erase this before you all judge how bad I spell. Okay, and then lastly, the rotation is a turn, right? So I here am sliding up and over, or I'm sliding over and up, whichever way you want to look at it. So that must be that slide. All right. Which triangle congruence theorem proves the two triangles congruent? All right, so let's talk about this a little bit. I know that this one tally mark, this one mark means that it matches with this one. So I could say that AC, line segment AC, is congruent to line segment CE, right? So those line segments are the same. And then let's pick a different color. We have BC. Oops, you won't be able to see that. So BC is congruent with CD, right? So this is a side, this is a side, and this, right? So these two are those vertical angles, which I know we talked about before today. So not as much as we will because they're going to be everywhere. Vertical angles, what does that mean? Well, that means that this side, and you cannot see that line really because it's white, whenever two lines cross like these do, The angles that are across from each other, like verticals, like I think of it like that. Can you see that? That, right? Those angles are going to be the same. So that means that I have a side, I have an angle, and I have a side in that order. Order matters. All right. So this is side angle side. Clear this, do this, and side angle side. Okay. What transformation would map the left pre-image onto the right image? Now, most of you in class were doing right with this. You may see that this is a flip, and the flip is the reflection. Okay. When I look in the mirror, I'm seeing the opposite, the flip of me, right? You never actually see yourself without some sort of reflection. That's why it's this one. Get through these quick. Oh, hooray, I have a power up. It's going to remind me 17 times to use it. That's fine. All right. Got it. All right. If angle C, so I should write this down so I know it. It's going to say that angle D is congruent to angle C, and I'll show you what that means in just a second. DBA, they use 3 letters on this one, and I'll explain why in just a minute. And then which congruence theorem proves these triangles are congruent? All right, let's open it up. I know this information. So sometimes you can just write one letter like this, because if I say angle D, here's D, there's only one that comes out of it, right? Just like angle C, there's only one angle that we see here. So if there's only one and you don't have to worry about the other ones, you can just use that one. Otherwise, like this one, what we have to do, DBA, it has to go in that order. So DBA, so DBA. So DBA is congruent to CBA. So CBA, right? So that's going to go, and I know that that's really ugly and extra, but I wanted you to see that again, right? Those 2 angles are the same. Why did I have to say 3 letters? Well, if I said angle B, I wouldn't know which angle I was talking about, right? Because I could say DBA, I could say CBA, which are the same, but what about angle, technically, DBC? I mean, it's 180 degrees. It's a line, but we just need to be clear and specific. All right. So what's the answer? What's the question? Come back to it. Which congruence theorem proves these angles congruent? All right. Well, I know I have 2 angles, right? And I have to think of my congruence. What are the ones that can be? So we have angle, side, angle, 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 side, side, angle, side, and side, side, side. Those are the ones that show congruence, right? So I have 2 angles, I know, so it's probably not this one, probably not that one. Depends what the other things that I have. All right, so I need to know that one of the sides are the same. Well, if it's the one between the angles, that would say the the segment DB is going to be equal to the segment BC. It looks that way, but we can't do anything with looks. Looks are wonderful but fleeting. No, I'm just kidding. You obviously see that I am not the neatest drawer. That's a very hard word for me to say. I'm not very neat with my drawing. So if I quickly draw something, no one should trust that those measures are accurate, right? So we can't do that without some sort of proof. But we could prove that AB is equal to AB. They're literally the same line, so they are equal to each other, right? So I have an angle. Next to it is the angle, and then next to that is the side. So it is not this one, even though, yes, those are the parts that I know, but what the correct answer is angle, angle, side. All right, let me go back, do that, angle, angle, side, boom. Number 6. Sorry, guys. I know you probably haven't done all of them as I have. Okay. If angle L is congruent to angle O. I'm going to draw on here. Might be able to see enough of it to do this. Angle L, so there's only one there, and angle O are the same. Angle M and angle P, this one and this one, and MN is congruent to PN. MN, let me do a different color, red's good. MN is congruent to PN. All right, so I have two angles and a side. What is the order? Well, this one is not in between my angles, right? In order for it to be angle side angle, I would need to know that this and this are the same. But I don't know that. So it has to be angle, angle, side. All right. Which congruence theorem proves these triangles congruent? All right, so I see an angle. I see a side. What else is there that we know? I tell you before. Vertical angles, right? JM and LN cross each other. So that means that this angle and this angle are the same, right? I should have used a different color, but I didn't, but it's no big deal. So the question is the side between the angles? No. This is the angle. I'm going to erase it so I see better. This is the angle, and this is the other angle. This side is not between them. So that is why it's angle angle side. All right. Oh, look at that. Okay. This visual below shows that CD is perpendicular bisector of AB. Which of these statements are true? Which statements are true? Not of these statements. Which statements are true? So is AM going to be congruent to BM? Oops. Is AB perpendicular to CD? Is angle CMB equal to 90? And is CB congruent with CM? Okay. I need to make it bigger. All right. AM is equal to BM. Well, we were told that it is a perpendicular bisector, right? So of AB, right? So AB, if it's a bisector, I am not writing well. Bi means two. Sect means group, right? So we're going to cut it into two equal groups. So that does mean that this is congruent to this. Which statements are true? So this one is true. Is AB perpendicular to CD? That's what perpendicular means, right? It's saying that CD is a perpendicular bisector. So that must mean the two are perpendicular. CMB, is that 90? The definition of perpendicular is it meets at 90 degrees. Yes. Is CM going to equal to CB? No. And this is the one that I wanted to, I was referring to or thinking about. If I didn't say anything, that's why. On that first one, right? They're asking is CM, oops, we're going to pretend that's on the line, equal to CB? No. Now, one thing that is true, one thing that is equal to CB, if I could make it a little nicer, one thing that is equal to CB is CA, right? If any point on this line, I should say, any point on this line to these 2 points, so from here to here, as well as from here to here, all of those are going to be equal to one another, okay? So is CB equal to CM? Well, no, because we're doing the point that's on the line with a point that's not on the line, so that one does not work, but the other 3 do. All right. Oh. All right. And we can pick multiple of them, so that's what I'm going to do. All right, submit. Hooray. All right, given the point 1, 5, what would the new point after it's reflected over the y-axis? Oh, guys, let's just go. I'm sorry, I'm going to go here. I could go back. I'm going to do it the quickest way I possibly can. I'm going to use my reference sheet for a minute. Okay, oh, additional resources. Click on this. Okay, so rules are here. Down, 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 there, right? So it's asking if I'm reflecting it over the y-axis. So I'm going to look over here and find the reflection over the y-axis. I can see that they stay in the same spot. They stay, X stays where X was and Y stays where Y was. The change is the X value goes negative. So whatever it was, it's going to do the opposite. So what that means is that they're going to stay in the same spot. So not this one, not this one. Stay in the same spot. That one stays in the same spot. That one stays in the same spot. That one's wrong. Now, I want my X value to change since my Y value, since I'm going over my Y axis. So it's not this one. It is this one. Should have let you go through this. All right, very nice. Next. Beautiful. All right. The transformation from the blue pre-image to the orange image is a what? Okay. So if it was a slide, if it was a translation, right, then that means it's not changing direction. It is literally moving like this, up or down, right? Just like that. So it's not that. It could be a reflection, which is a flip. Okay, does that flip? Now, if it flips over the x-axis, right? Ooh, and it tells us the rule up here. Let's look at that in a second. If it flipped over the x-axis, that means that these actually stay in the same order. And what happens is the y value is made negative. But these ones switch spots, so that's not it, right? This is not a flip. This is a rotation. All right, it is rotating about the origin, right? And we can see the right angle here and the right angle here. So it's rotating 90 degrees. And in what direction? Well, a clock, remember, 1, 2, 3, 4. Hold on 1 second. All right, so as the clock goes around, I hope that I left off in not a weird spot. 5, 6, 7, 8, 9, 10, right? Clockwise goes this way. Counterclockwise goes that way, right? This is going clockwise 90 degrees. If it was counterclockwise, that would be 90, 180, 270. All right? So it is a rotation. It is 90 degrees. See, the clockwise, this is saying 270 clockwise. It's not. It's 270 counterclockwise or 90 degrees clockwise. This transformation is an example of what? All right. Is it flipping? Is it not something we've studied? Is it sliding? Oops, not flipping, sliding. Sliding. Oh, golly. Or is it turning? Right? This one is not flipping because there's definitely a different orientation. That wasn't the word. That's not a great word to do. But it's not in the same angle, right? It is rotating or turning. All right. So that is why it is this one. Sorry for all the clicks. I don't think you can see the animation tools. Hope you all are doing well. All right. Transformation. Well, we have been doing, maybe I'll type it, rigid transformations, which means that they have stayed, not starred, stay the same shape. Can't type either today. Does this one stay the same shape? No. It either got bigger. If it went from the red to the blue, it got bigger. If it went from the blue to the red, it got smaller. So that is not a rigid transformation, non-rigid transformation. Dilation, we'll talk about it later. All right. Oh, gosh. Oh, is it going to take stuff away? Given point A, -5, 2, what would be the new point after it's rotated 180 degrees? Well, I'm going to go back here, rotate 180, right? So that is this one here. X and Y stay in the same spot. We just flip the signs. So flip the signs, flip the signs, flip the signs. So this one is going to be a +5, and this will go to a -2. All right, so that's my answer. Not that one, not that one. +5, -2, not that one. Okay. All right, BAE, AE equals B is congruent to BE. AE and BE are congruent. CE and DE are congruent. Now, someone asked in my class, and it was a great question, like how do you know which one has 1 tick mark, which one has 2 tick marks? That doesn't matter. I could have done 3 and 4. It doesn't matter. All that matters is that tick mark and tick mark match. All right. Okay. Which triangle congruence theorem would prove the triangle's congruent? I have 2 sides, right? What else do I have? See, this vertical angle thing keeps coming. Vertical angles are congruent. This angle here and this angle here. So it's not that they're not congruent. Angle, angle, side. No, I have 2 sides, not 2 angles. Side, angle, side. That one looks good. And angle, side, angle. Nope. It has to be that one. And it does help that it's in the middle. All right, this is an example of the reflection over. It is moving left and right. And I think when people saw that, they're like, oh, that means the X value changes. Yes, precisely. But when the X value changes, that means it's going over the Y axis. This, pretend that's, oh, select, I can use that, right? Ooh, there we go. This is where it's reflecting, right? It's reflecting over here, which is the Y axis. All right. Given the point 92, what would be the new point after it's been rotated 90 degrees clockwise about the origin? So rotation rules clockwise, 90 degrees about the origin. It looks like, and I'm going to write this down, X is going to become, oh, well, yeah, I'm writing it for the other thing. XY is going to flip. Y comes first. The second one goes to the first spot. The first spot goes to the second. And I also make it negative. All right. So I'm going to go back so you can still see it. I love that. Okay. Because that zoom tool is for you. So I want to switch where they are, -2 and 9. And then I have to make my X negative. So that's why that answer is here. Okay. All done. Hooray. So that is how you do that. Please watch it. Try it on your own. Ask me questions before Monday. I will check my email this weekend if you have some questions. And good luck studying.